Trust in IoT ecosystem, as in relationships, is based on individuals, devices, or agents who act in a way that maintains positive future interactions rather than acting on the basis of personal interest. This simple quote indicates the importance of trust amongst communicating devices. Social IoT or SIoT is an alternate architectural pattern for IoT which involves IoT devices with social behavioral attributes. A SIoT device based network uses social collaboration between IoT devices acting as service users or service providers or both to enable low latency collaborative services and applications. A key challenge in implementing an SIoT based service network in a multi vendor environment of heterogeneous devices is trust. The challenge is in prioritizing and selecting trustworthy service providers autonomously and independently by a service user IoT node. The problem is significantly tougher to solve in networks with IoT devices that are resource constrained. In this session, the participants shall be introduced to the social IoT concept and how it compares with the traditional architectural pattern for building IoT solutions. The topic of trust management in social IoT networks will be next introduced, including a discussion on the variety of security attacks possible in a social IoT network. Lastly, trust models used in online social networks, OSNs, and online service-based networks will be discussed and how they can be adapted to work with social IoT. I would first take this opportunity to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us a galaxy of experts. I would first request Professor Emin Huda Sir, Director, Bharati Vidyapeeth's Institute of Computer Applications and Management, BVI CAM, and Executive Vice Chairperson, IEEE Delhi Section, to address the participants with his inspiring words.
Good evening, one and all. At the outset, let me take this opportunity to welcome my today's valued speaker, Mr. Nishint Narang, who, despite his all busy schedule, has accepted to give this talk and share the knowledge as part of knowledge dissemination program. So thank you so much, Mr. Nishint, for having been with all of us. I also take this opportunity to express my gratitude to all the heads of the professional societies who have collaborated for this program, and particularly my friend Mr. Ajay, who is the chairperson of Industry Relations, and the former chairperson of IEEE Delhi section, Professor Subramanian, who keeps attending program right from the beginning. And finally, I am thankful to all the participants from various parts of the country and abroad who keeps on waiting for this webinar series, which is IEEE, IETE, BVICAM weekly Saturday evening webinar series. And this is 140th lecture of that series. Many of you are aware that this series was started in the backdrop of COVID-19 in May 2020. And since May 2020, we are continuing this series. This is 140th edition of that. You'll be also happy to note that this series, during the course of the nominations received from all over the world at IEEE US, was adjudicated as the best and the most sustainable series in the continuing efforts of sharing knowledge with the fellow professionals for the purpose of keeping them engaged for some learning related activities, and has been adjudicated at the best and was awarded by IEEE US in last November to IEEE Delhi section and all of us. So this credit goes to all my team and all the participants who from different parts of the country and abroad. By now, we have the participation count of closely 2.5 lakhs people. Of course, there may be many, but it is a count when we are talking of 140 lectures together. So now the COVID-19 we started, and again, the same COVID-19 is spreading in its wings again, and in many parts of the world, including India, various advisories are being issued. So my request to all of you, be careful. The today's topic, which is very, very important, and very apt, and very useful, is trust model for social IoT network. Dr. Ritika has given a new basic introduction, and for knowing more details about it, we have invited Mr. Nishint Naran, who will be talking with all of us. To me, it sounds very simple that we normally say that a chain is as strong as its weakest link. Exactly in the same way, when multiple IoT devices are going to be connected in an IoT framework, and different devices are going to provide different type of services. So the authenticity and the reliability of that IoT network, or the trust factor of that IoT network, will be dependent on the least possible trustworthy service, or the least trustworthy IoT node connected in that IoT environment. So in that IoT environment, in that IoT framework, whichever will be the least trustworthy, that will become the kind of the authenticity or the trustworthiness of that network. So how to ensure that every node, IoT node, which is going to get connected in that platform, get connected in that IoT environment, should be as trustworthy as we expect for, in terms of the quality of the services being provided, in terms of the reliability to be offered to the users, and etc., etc. And that is the reason why we all of us are here. Dear friends, for next webinar also, the registration is open. If you have not registered so far, do register nowadays. On the basis of instead of every week, now we are conducting it every alternate week, because we have in between started another series of media lecture series, which we conduct in the intervening period of this particular week. So thank you so much for having joined to all of us. I speak more. Instead of that, we wanted to listen more from the experts who keep on engaging himself in activities related to users in his industry. So we'll save time for that point of view, and we'll keep the floor open for our valued speaker, Mr. Nishint Nagran, to enlighten us that how and in which way we wanted to be careful, and how and in which way we wanted to avail the services. And thank you so much. With this note, that फूलों की तरह फिर खिलेंगे हम, and next Saturday एक नए टॉपिक के साथ फिर मिलेंगे हम. Wish you all the best. God bless you all.
Thank you, sir. With this, I would now welcome amongst us our expert speaker, Dr. Nishit Narang, sir, with an e-bouquet.
Thank you so much. Thank you.
बुके की खुशबू ऑनलाइन महसूस की जा सकती है. और ये खुशबू ऐसी है जिसे किसी एक जगह गिरफ्तार करके कैद करके नहीं रखी जाती. खुशबू के बारे में मैंने 2 पंक्तियां लिखी थी कि बड़ी मुश्किल में हूं, कैसे इजहार करूं, तू तो खुशबू है, कैसे गिरफ्तार करूं. तो ये खुशबू डॉक्टर रितिका शेयर कर रही है, लेकिन निशिन तक पहुंच रही है. इसे हम में से कोई गिरफ्तार नहीं कर सकता. थैंक यू सो मच.
Dr. Nishit Narang, sir, is a group leader and associate professor in Computer Science and Information System Department at BITS Pilani. Work Integrated Learning Programs, WILP Division of Campus Delhi. His areas of expertise include computer and communication networks and security. He teaches various courses in these areas to working IT professionals as part of BITS Pilani WILP. Nishit sir did his BTech and PhD from IIT Delhi in Computer Science and Engineering. Before joining BITS Pilani, sir worked for over 23 years in the IT industry and gained extensive experience working on various IT projects in the domain of communication and networking. Besides working on terrestrial, satellite, and mobile communication networks, he has also helped develop industrial and consumer IoT solutions involving industrial automation, smart city solution, and consumer wearables. Over the years and across his projects, he has focused extensively on information security and cyber security. Nishit sir is also the co-author of 4 technical books in communications domain. His books were published by McGraw-Hill and sold internationally. We are honored to have you amongst us, sir. I now will request you to kindly enlighten the House. Over to you, sir.
Yeah, thank you, Dr. Ritika. Thank you, sir. Thank you for the invitation and giving me this opportunity. Let me just start by apologizing for the delay in start. I hope we can cover up that during the presentation. So let me just, without much ado, share my screen so that we could start. Okay, so yeah, so I'm sharing my screen. Hopefully, it should be visible to everyone.
Yes, sir.
Okay. Okay, so as Dr. Ritika introduced, the topic for today's discussion is trust models for social IoT networks, and I've purposefully put in the suffix and introduction because it's a vast topic, and what we'll basically be covering is more of an introduction to this topic today. So, okay, let me. Okay, so let's start by just giving a definition to this term social IoT, or in particular, what do we mean by a social IoT network? Well, the social IoT network is itself broadly consisting of three key things, and all of them are known things. I mean, I'm pretty sure everybody's pretty familiar with these topics. One of them, of course, happens to be IoT. It has to be there. Social IoT is an IoT network. So it's an Internet of Things, a network for Internet of Things. It has the social networking aspect tied up with the IoT network. So we are all familiar with social networks. I'm sure we've been using social networks, at least in the online form, the online social networks, Facebook, LinkedIn, all of them are online social networks, and all of us are using those networks. So when IoT networks, which is basically a network that connects everyday devices, things over the internet, clubs its wings with facets or aspects related to social networks, that becomes the key ingredient. Sorry, I think I lost sharing.
Yes, sir.
Okay, should be good.
Yes.
Yeah, so those two become the key ingredients of a social IoT network. But any network has to have a purpose for existence, right? We're not just saying there's an IoT network and the devices also kind of connect as if it was a part of a social network. There has to be some use to it. So we're basically saying that this kind of a network can be very useful in providing device to device services. So the third ingredient that we're saying is part of a social IoT network is the variety of service models that exist, wherein a service user device, an IoT device which is can act as a service user, can take certain service from another IoT device in the same network, which is acting as a service provider. So if I, in very simple terms, say what is a social IoT network, it's an IoT network, but it follows a slightly different architectural paradigm, which is a architectural pattern that is more closer to our social networks. Now, I'll just explain that a little further by talking about how the IoT architecture has evolved over time. So when IoT just started, I think the initial solutions were all following this kind of a centralized architecture as what you can see on the screen. And I say it's a centralized architecture because if you look at bulk of the business logic, that existed on systems that resided on a central cloud. Okay, so we're saying primarily the services that were being offered were driven by the cloud-based platforms. That is where the services were hosted, and different things or these devices used to connect to the cloud platform via an intermediate network, which often passed through a gateway and then connecting over a wide area network to the cloud. I like to call this kind of an architecture more of a centralized architecture. A lot of IoT solutions that we see around us follow this kind of an architecture. Now, over a period of time, a new architecture evolved, which is what we are calling as the distributed or more like a mesh architecture, where the IoT devices are connected to each other in a mesh kind of a topology. Right? So IoT devices, rather than being disjoint, not connected to each other, and only being connected to a central cloud, are now connected over a mesh. So this car over here gets connected over a direct point-to-point link with another device, which connects to a bulb, which is another device. All of them are kind of mesh connected to each other. This is basically, sorry, apologies for that. This is basically what is helping or which is driving the architecture more from a central cloud-based architecture to an architecture which is more M2M or machine to machine kind of an architecture. Right? So that's what an M2M over here stands for. And this kind of a M2M architecture is more and more today visible whether we look at the Internet of Vehicles, which is a special form of an IoT network. We talk about V2V, right? Vehicle to vehicle communication. We talk about Internet of Energy, right? Where smart meters and electric devices are connected to each other. We also talk about the Internet of Sensors, which is also a wireless sensor network, is also a kind of a mesh topology where sensors connect to each other in a uh, mesh kind of a distributed topology, right? So in a sense, we're not saying that one architecture is better or the other is better. We're just saying that both architectures exist and both of them have their own purposes. The central architecture is more utilized in cases where the cloud happens to be the central store or the central place from where the services are offered. But we all do understand that there's a latency involved in the device going to the cloud and then getting a response back. It's at least, let's say, a few hundreds of milliseconds of latency. And a lot of IoT services which are sensitive to time or sensitive to that kind of a latency may not work very well with a centralized architecture. Um, just to throw that or give a better idea to that, think of, as I said, Internet of Vehicles. An Internet of Vehicles can be seen as a network where the automotives are connected to each other and they implement different kind of use cases. For example, if you have all self-driving cars, then one of the use cases of a Internet of Vehicles scenario could be how do these cars detect collision and immediately prevent or communicate to each other to prevent that kind of a collision. Now, these are latency sensitive kind of use cases. And if I say that this kind of a solution has to be built using a centralized architecture, it won't work because if the cloud platforms are making that decision of imminent collision and giving guidance to prevent that collision, it's a long latency by, I mean, it's matter of hundreds of milliseconds here, which by the time the collision might already happen. So we want to take split millisecond kind of decisions, which are faster taken in a more mesh kind of an architecture. So each architecture has its own benefit, its own pros and cons, but it's important to recognize that both kind of architectures do coexist. Now, social IoT is more like a manifestation or an enhancement of the distributed IoT architecture. So in that sense, I'm saying a social IoT is kind of an extension to the standard M2M or machine to machine distributed architecture that IoT follows. In that sense, the term social in social IoT comes from the social networks itself. So we're basically saying that a social IoT network is actually a social network for IoT devices. Of course, the IoT devices are connected to each other in a mesh kind of a topology, right? It's a M2M network. But what is different from a standard M2M network is that these IoT devices have some social behavioral attributes with them. Okay, so think of every device as a smart device with some level of artificial intelligence, right? So it is kind of mimicking human intelligence. It's saying, okay, every device is its own, has its own behavior, it has its own AI properties, so it has its own social and behavioral traits. And because in that every device has its own social behavioral attributes, it also has the ability to decide which other IoT device in the network it wants to connect with. Okay, thereby helping it to form a social network between devices. Okay, so think of a social network between devices as completely analogous to what we have as humans. We have online social networks, we have physical world social networks. The purpose of these social networks is to connect people together. A social IoT network does the same thing, but it does so with IoT devices. Now, the essence of social IoT is in enabling collaborative computing. So instead of saying that everything is managed by a cloud centralized platform, we're saying no, it is the devices which implement a use case or a solution, and they do that by collaborating amongst themselves. Right? Now, you could say that this is possible to do even in an M2M network where devices can connect over a mesh topology. What's special about social IoT? What's special about social IoT is that you're giving the decision or you're giving the right of which device to communicate with or which device to connect with. You're giving that ownership or that decision making ability to the device itself. So because this device has all the associated artificial intelligence and it has the decision making ability, it can decide which social net connections it wants to make with the other IoT devices and which ones it doesn't want to connect with. Right. So just like we decide, I mean, if somebody asks me to connect over a LinkedIn network or a Facebook network, I make a conscious decision, right? That's how we are saying the IoT devices also do that. Now, if devices have to decide who they want to connect with or who they don't want to connect with, and let us call this a social tie. So, who do I want to make a social tie with? Or who do I don't want to make a social tie with? There has to be basis to that decision making. Right? So, what is that basis of decision making in an online social network? So, somebody sends me a friend request, let's say on Facebook. What helps me make that decision? When do I connect to a person socially on a network like Facebook, or let's say on a professional network like LinkedIn? When do I accept that connection? When do I not? Right? And a major ingredient that goes behind my decision making is how trustworthy I find the other party to be. Okay, so I'm essentially saying that one of the key ingredients of any form of a social network, whether an online social network for humans or a social IoT network for IoT devices, it's trustworthiness management, right? So basically, the ability to be able to assess or measure trust and use it as a basis to decide how do I make my social connections or my social ties in a social network. So before I get to that topic of trust any further, let me just briefly say how trust manifests itself in online social networks. So we've already said, okay, um, you get connection requests on a social network. So over here we have two people, Alice and Bob, and Bob has sent a connection request to Alice. Now Alice is in two minds. Alice doesn't personally know Bob, so Alice is making that decision. Should I connect to Bob or should I not? I mean, of course, Bob could be an angel, but it could be a malicious user as well. I don't know. Can I trust Bob? Now, this question, can Alice trust Bob to make that social connect over the social network? It's always in context of something. What is in context? We're talking in context of some service or in context of some topic. So here we are saying for Alice to make that decision, the target is Bob. Alice is trying to make a decision considering Bob as the target, but there has to be a topic associated, and that topic is basically the service offered by Bob. So if I want to make a connection to Bob, if I want to make a social connection with Bob, what is it that Bob has to offer to me? What do I gain by making that connection? Right? So that's the topic. And in context of that topic, I'm trying to make an assessment to can I trust Bob for that service or for that topic? The same, okay, before we get to the same thing in social IoT, let me also say that trust is a very, very complex thing to measure because trust has what we call as the START property. So START over here is actually an acronym which stands for subjective, topic dependent, asymmetric, risking betrayal, and time sensitive. What do we mean by that? So if I talk about trust, right, it's subjective, right? When I say subjective, it basically means very, very difficult to measure. It's hard to put a value corresponding to trust, right? How much do you trust me in delivering this talk? Can you say a number? Can you say 2.5, 2.6? No, it's subjective. It's always topic dependent. Okay. So if Alice has to trust Bob, okay, what is the topic? The topic could be movies, the topic could be automotive. Now, Bob may be an expert in automotives, and therefore Alice may want to trust in Bob's opinions when it comes to Bob's recommendation of automotives, right? He may say, okay, go and buy this car. And Alice will trust Bob because Bob is an expert in automotives. But when it comes to the same thing with movies, let's say, Maybe Bob has no awareness about movies, and Alice may not trust Bob on his recommendation of movies. So all we're saying is that trust is always topic dependent. You may trust a person for certain topic, but may not trust the same person on a different topic. Trust happens to be asymmetric. I may trust you on something, but you don't have to reciprocate that. You may not trust me on the same thing. Right? It's risking betrayal, which basically is also considered a kind of an attack, which means that I may trust you, but at the same time, I always have to be aware that at some point in time, I may be betrayed. There's always a risk of betrayal. Right? Nothing is absolute foolproof. There's no absolute trust. Right? So there's always an element of risking betrayal. And trust happens to be time sensitive. Right? Trust may grow over a period of time because we talk so much that eventually I'll start to understand you better. And therefore, over a period of time, my trust in you grows. It could even go down because I start to see the wrong things in you as we interact more and more. And my trust in you may go down. So trust is something which is time sensitive. Now, because of the start properties of trust, it becomes a very, very difficult thing to assess and manage and measure. And that's primarily the problem that exists in any kind of a social network. The same problem manifests itself in a social IoT network. And we're saying a social IoT network is actually nothing but a service network. Devices are connecting to each other because there's some topic, there is some service. There's a service that a device offers to the other device, and it is in context of that service that devices are connecting to each other. So the question that devices are asking are still the same. B is offering a service, let's say S, and A is a service user device. It wants to make a decision. Can I trust device B for topic S or for service S? Right? So the same question arises. How can a node trust another node in a social network? The same kind of start properties of trust manifest themselves even in a social IoT network. Yet, I would say that trust in a social IoT network is a lot more complicated to manage than it is when it comes to an online social network or any other form of a service network. Why? Because we are dealing with a heterogeneous network. We are dealing with devices which are multi-vendor devices. We are dealing with devices which are of different types. Right? These devices could have their own resource consideration. Some devices could have tremendous amount of storage. Others may be storage constraints. They're devices which are very, very resource constrained devices. Okay? That's possible with IoT devices. So you can't run a very complex model to assess trust because the IoT devices may not have the kind of resource availability to run those kind of models. And there are a variety of attacks that can be possible. Right? All forms of attacks that exist and security challenges that exist in an IoT network can manifest themselves also in a social IoT network. So how do we measure trust? Right? Since trust is something which is subjective, it has its start properties. Is there a way in which we can measure trust and use it to form our social ties in a social network? To understand that, let us try to see how the same problem has been solved in online social networks and even service networks. And I say e-service networks basically to highlight all our e-commerce platforms and service platforms that are available and accessible over the internet. Okay? I mean, an example of an e-service could be, let's say, an Amazon marketplace or a Flipkart marketplace where there are service providers or sellers and there are service users or buyers. How does a buyer trust a seller for whatever products he's selling? There's still that element of trust, right? So whether it's an online social network or even any kind of a marketplace or a service network where there's a service provider and a service user, trust plays a big role. So how do I measure trust? Now, there are three key statements that you would see on the screen. Each of them are independent in their own rights, but you can tie them up together one way or the other to identify or find out what could be a way or an approach to measure trust. So the first statement reads, trust is the basis of all interactions. So what that really means is if there is an interaction between two entities, it will only happen if there is trust. Okay. Or in another way, in a deeper sense, you can even say that the volume of interaction that two people have or two entities have is directly proportional to the level of trust that they have. That's what the first statement means. Trust is the basis of all interactions that people, any firm entities have amongst them. Okay. The second one says that influence happens to be a tool that triggers the trust. Okay, what does that mean? So, if Dr. Ritika says that Dr. Nishit happens to be so and so person, he comes with that kind of an academic degree, he's worked so many years in the industry, there's a level of influence that is being created. And that is indirectly acting as a tool that triggers some level of trust in my ability to be able to deliver this kind of a talk. So that's the role of influence as a tool to trigger trust. But how do you propagate influence? Right? How do you propagate influence in any marketplace, in any social network? Recommendations. Right? So recommendation happens to be one of the most often used methods for propagating influence. And primarily it is these three that have been used across a variety of trust models that have been designed for online social networks or service networks alone. So look at online social networks, Facebook, LinkedIn, right? How do people decide whether to make a social tie or to not make a social tie, right? And let me phrase that question a little differently. Let me say there's a Facebook network, right? Now, there's in a Facebook network, there are friends, there are ties. Can I even say which is a stronger tie in terms of its? So every tie is a social tie, but not all friends are equally good friends, right? So there are some very close friends, there are some average friends, there are some frenemies, sometimes friends, sometimes enemy, and there are some outright enemies, right? So I look at a Facebook graph, all of them are all every node in that graph is actually a person, and every edge in that graph is actually a social tie. But a simple graph doesn't give me an assessment of the strength of the social tie. How strong is that social tie? How much do two people trust each other? And that is what I'm calling as the strength of that social tie. Okay. Now, online social networks use the first principle over here to measure the strength of a social tie, or in other words, the level of trust that two people have in themselves. So they're saying because trust happens to be the basis of all interactions, the corollary or the alternate thing is also true. More the interactions, higher the trust. So, in some sense, let's say I have 10 friends on Facebook, but I don't communicate with the same level of, I don't communicate the same volume with everyone. I mean, through some people I'm talking every day, others I'm just talking once in a week, let's say. So the more the interactions I have with a person is a demonstration of the higher level of trust I have with that person because I'm willing to share a lot more with him than somebody else. Right? So that's basically saying the reverse of what the first statement was. Trust is the basis of all interactions, and therefore, more the interactions, higher should be the trust. So this is a method that online social networks use to measure trust, or in other words, the strength of each individual social tie. How strong is that social tie? The more the interactions, the higher is the strength of the social tie. This is how social networks try to solve that problem. Online social networks try to solve that problem. In service networks, like let's say you would have all used marketplaces like Amazon and Flipkart. How do they try to solve this problem? They go this way around. Recommendation is a method of propagation of influence, and because influence is a tool that triggers trust, therefore recommendations can trigger trust. Right? So if there are service users and service providers, if there are sellers and there are buyers, let us start taking recommendations. So if somebody has bought something from a seller, can you give a rating or a recommendation for this service provider? And I keep collecting all these recommendations. The higher the ratings, the higher the reviews, the better or the more the trust I have in that service provider. Okay, so that's the kind of model that a lot of service networks use. Right? Now, the question is, can I use the same methods for a social IoT network? Can I use one of these two methods? Can I look at the volume of interactions that devices are having between them to say, okay, what is the strength of a social tie between devices, like I do with the online social networks? Or Can I go with a recommendation based system? So if people recommend devices saying, okay, this is a good device, happens to be offering very good services, can I use that kind of a model? So that's the question. Now, the answer is yes and no. I may not be able to. Right? So some of these models may fit well with certain kind of social IoT networks, but others may not. So what is the decision making? How do I make those decisions? So what makes me say that some models may work, may not work? Why is it a yes and a no? So the importance is lies in understanding that there are four key things that we are looking at when we are specifically focused on a social IoT network. As I said, an IoT network consists of IoT devices, and I can make no assumption about the resource capabilities of these IoT devices because they can be heterogeneous devices in my network. Some of them may be resource constrained. So not every IoT device in my network may have the computational capability, the storage available, even the battery power to run very, very complicated models for assessing trust. And therefore, there are four key things that when I'm assessing any trust model and I'm saying, okay, can I use it in a social IoT network? These are four things I need to understand. What is the volume or amount of information that needs to be exchanged so as to be able to make a decision about the trustworthiness of a node in the IoT network. Right? Now, in a recommendation-based network, we know that there's enormous amount of data that is flowing. Every transaction that I make on a marketplace, I'm asked to rate the service provider. All those ratings are getting collected. So there's enormous amount of information. It all works because all these marketplaces are following more of a centralized cloud-based architecture. The marketplace is hosted on the cloud. All of the data is collected on the cloud, and the analytics that goes behind the scenes to be able to rate service providers is all happening at a cloud. When I try to do the same thing in a M2M social IoT network within IoT devices, I may not be having the ability in IoT devices to process so much of information. So what is the amount of information dissemination that is required over the network to be able to assess trust? That's one factor to be looked at. How much storage is needed in the IoT devices to store all of this data that is getting exchanged over the network? That drives the storage requirements. For every computational run of my trust model, what is the volume of information that I need to process? Right? And how frequently do I need to do this recomputation? In other words, saying because we said trust is time sensitive, the last T of the start properties, I of course have to remeasure trust. Right? How frequently does my model require me to recompute? Is the fourth factor. Okay. Now, considering IoT networks, we basically are looking for a model which does not require a lot of information exchange, which can do with little storage requirements, where the volume of information processing is not huge, and the recomputations that are needed to be done can be over longer durations. Right? So I'm not giving exact numbers or values over here because it differs network to network, but comparatively, I'm saying that is what I'm looking at. And therefore, it is not always possible to use the kind of models that we use in online social networks and service networks and apply them in social IoT networks. So what can we do with social IoT? What kind of trust models can we build for a social IoT network? Well, there's a lot of work that is going on in this space, and a lot of different trust models have been proposed. Now, of course, I can't get into all of those models, but a good way to understand those models is to look at the broad level categories in which those models fall into. So in one of the papers that Elgomeri et al. Basically published, they tried to look at all possible trust models and classified them into three bucket categories. They said, okay, a trust model can either be a graph-based model or an interaction-based model or a hybrid of these two. So what do we mean by that? Of course, I already talked about interaction-based model. Interaction-based model is like what we talked of in the online social network case. It says higher the node interactions, greater is the trust between those two parties. Right? So what do I do in that kind of a trust model? I try to collect the interaction data. How much do people talk to each other? And based on the volume of interactions, I try to estimate the strength of their social tie, or in other words, the trust that they have in each other. Right? That's an interaction based model. Without having to say anything more on this, I think it's obvious that an interaction based model can only work with the phenomenal amount of data that has to be collected and a lot of analysis that needs to be done on that data. It can, okay, I'll come to a little bit of a pros and cons on this a little later. A graph based model, on the other hand, tries to use just the graph structure to deduce trustworthiness. What do we mean by this? So if I give you a Facebook graph, okay, I say, okay, there are 10 people on in Facebook, and each of those people are represented at 10, as 10 nodes, and this is their social tie graph. So this is how they're connected. Can you just look at that graph and tell me what is the strength of each social tie? Now, this may look like something very difficult to do. How can I just look at a graph and say what is the strength of each tie? But that's something which people have worked on, and that's possible. I'll just come to that in the next slide and give you how this kind of a model works. How can a graph-based model work? Now, the beauty of a graph-based model is that it doesn't depend on a lot of dynamic information. How often would a Facebook network graph change? Not as frequently as the volume of interactions. So I'll say it's more like a semi-static graph structure. It changes, but it changes a lot slower than the volume of interactions that are happening. And therefore, a graph-based model can help you give a reasonably good estimate of the strength of every social tie by just observing how the structure of the graph is changing or how it currently exists. Okay, so I'll just come to this in a little more while to help you understand how this works. And then there are hybrid models which say, okay, each of these, whether a graph-based model or a dynamic interaction-based model, each has their pros and cons. A graph-based model cannot be very accurate. Right? It can, as I said, it helps you deduce trustworthiness, but it cannot be 100% accurate. It can't even be a 90% accuracy. There's an element of doubt with graph-based models. On the other hand, dynamic interaction-based models are known to be more accurate, but they require a lot of data processing to happen. So hybrid models try to balance the shortcomings of one with the other benefits that the other brings in, making a more kind of a hybrid model. Okay? Now, while this kind of a categorization is useful, it's more applicable to social networks, as in the online social networks, right? Because that is where a lot of interactions happen. That is where the graph structure exists. So it's more useful for online social networks. But when we look at service networks, like Amazon's and all these marketplaces, different kind of models are useful over there. So there are ratings based models, which we just discussed. Every transaction that happens over the marketplace, a rating is given to that transaction. Over a period of time, all these ratings are accumulated to deduce, or to not deduce, but to calculate the trustworthiness of a service provider. Of course, just like interaction based models, a rating based model requires a lot of data processing to happen. So a improvement over rating based model is what is called as an opinion based model. And we'll just come to it. How does an opinion based model improve upon a rating based? So an opinion is an opinion of a person. If I just come to you without giving you all the ratings that I've given to different service providers in, let's say, the last 1 week, if I just come to you and tell you, I think this is the right service provider to go to. That's an opinion that I'm sharing with you. I'm not giving you hundreds of ratings that I may have given over the last 1 week. I'm just coming to you with a consolidated opinion after having executed, let's say, 100 transactions. I come and I say, okay, last week I made 100 transactions. A summary of those 100 transactions is, in my opinion, this is the best service provider. So that's what an opinion based model tries to do. It tries to aggregate ratings together, summarize them, and then provide them as an opinion. And then there are cross-integrated models, and cross-integrated models are models where people try to deduce trustworthiness from one kind of a social network or service network and try to apply it into a different network. So let's say if we have friends on Facebook and you send me a connection request on LinkedIn, I'm more likely to accept that connection because I already know you on a Facebook network. So it's a kind of a cross-integrated model. It may not necessarily be a cross-integrated model in the sense that both the kind of networks may not necessarily be online social network. And I'll talk about a kind of model where people have tried to use a relationship that they've discovered in an online social network and tried to use it in an IoT network, right? So those kind of models also exist. Now, a little bit I'll talk about the graph-based models because this is something which is very, very unique. Where, as I said, can you look at a graph structure and say what is the strength of every social tie? And the groundwork for these kind of graph-based models was actually done by a sociologist. I mean, the guy wasn't even a computer scientist or some coming from a computer background. He was a sociologist, an American sociologist by the name of Mark Granovetter. And his paper, which he published in 1973, The Strength of Weak Ties. If you look at today, it's one of the most cited papers of our times, right? Interestingly, though, this paper, The Strength of Weak Ties, never got a lot of citations in the initial part, many decades after it was published. Only very lately, since 1990, has it started to gather a lot of citations now. So, what did Granovetter do? Granovetter, in summary, demonstrated that there's a degree of overlap between any two individuals' friendship network. And this degree of overlap directly determines their social tie. Let me say that in a slightly different sense manner. Let's say there are two people A and B. Okay, let me just try to see if I can write that down. Okay. Okay, so let's say there are these two people A and B. And what I'm trying to do is to figure out how strong is this social connection between A and B. Okay, how are they close friends? Are they just friends? Are they just acquaintances? Are they frenemies? So, what kind of a strength? What kind of a social tie do they have? Now, let's say FA is the set of all friends of A, and FB is the set of all friends of B. Right? So both of them have their own friends. Sorry, I'm not sure why. Just give me a second. Okay, I think there's something wrong with the pen, so let me not use that. Uh, okay, so let me just try to, or let me just use the mouse to write. Okay, so I said you have FA and you have FB, right? And the overlap is basically how many common friends exist between these sets. I'm saying intersection, and that's the mathematical intersection. How many friends of A are also friends of B, right? And vice versa. How many friends of B are also friends of A? So basically, we're saying how many common friends do we have? And if I divide that with the total number of friends that A and B have, which is nothing but FA union FB, right? Let me not write it, but it's the union as you understand. So if this I can somehow measure, right? Granovetter said that the strength of the social tie between A and B, if that has to be determined, it's directly proportional to whatever this ratio is. In other words, I'm saying the more the number of common friends that we have together, the more is going to be our social tie, strength of our social tie. Now, there was no data to prove Granovetter's hypothesis. So let me just say that this is the hypothesis that Granovetter came up with. There was really no data, but it's more like a gut feel. Think of it. If you have a lot of common friends, what's likely to happen? You're likely to meet each other a lot more. So if A and B have a lot more common friends, A and B are going to meet each other a lot more frequently. Whenever there's a birthday of a common friend, there's an anniversary of a common friend. Both A and B are common friends, so they'll be meeting at that party. The likelihood that A and B get close and the strength of their social tie grows is more if they have more common friends. So that's the hypothesis which Granovetter came with. Nobody bought it really because there was no data to prove his hypothesis, and therefore for a very long time that work was just there for somebody to appreciate or somebody to pick up. But what happened in 1990 is a group of researchers, Onella et al., they picked up the work of Granovetter and they said, there's a lot of data that we have today. Can we look at this hypothesis and try to verify this. So what they did was they collected all the call data records that are available in mobile communication networks. And what is a call data record? A call data record is an interaction. How frequently do I pick up my phone, call you, and how long do I talk to you? That's an interaction. That's a measure of interaction. So what Onella et al. They did was they basically quantified from these core data records if there is a correlation between how much we interact with each other and the neighborhood overlap as Granovetter had highlighted. And what they found was something very interesting. They found that there was a direct correlation between the volume of interaction that was happening between any two individuals and their neighborhood overlap. And we've already said what is the level of interaction indicating. The level of interaction is indicating a higher or a stronger social tie or a more trustworthy relationship. And these guys proved that it is directly proportional to the neighborhood overlap. And that's how graph-based models evolved. So people said, okay, if there's a direct relation between how much I interact to another person, and it's directly related to our common friend graph with to our neighborhood overlap, I can just look at a social network graph and be able to deduce or at least predict the strength of a social tie by just looking at that graph structure and computing for every individual this kind of a ratio, which is what we call as the neighborhood overlap. So that's how graph-based models evolved, and today they are used in a lot of trust models because they don't require a lot of data to be processed, and they can just look at how a graph evolves. Each time a graph evolves, let's say every 2 days, I can recompute my trust factor looking at how the graph has changed over the last couple of days. Right? So I don't need to look at a lot of interaction data. Of course, there are papers which talk about interaction-based models and how they are very useful in predicting accurately the strength of social ties. We all understand they exist, but they are quite data intensive. There are ratings-based models, and as I've said, they're very, very frequently used in e-commerce networks to basically assess the level of trust that a person can have on a service provider. There are opinion-based models which have been published and which, as I said, is more of a consolidated view on all my past transactions. Rather than giving you 100 ratings on 100 transactions that I've done, I consolidate all those ratings and instead give you my some opinion on it. And therefore, the volume of data exchange that we are doing over the network is reduced in opinion-based models. Okay, so cross-integrated model is, as I said, an interesting idea, which was, I think, first proposed in a paper called M4M, Machine for Machine, where they tried to propose how, looking at a social network graph, I can enable or identify trustworthy IoT devices. And what they basically proposed was, see, an IoT devices cannot exist in isolation. It has to be owned by someone. So every IoT device has to have a device owner. And assuming that the device owner is also on some online social network like Facebook or Twitter, this paper proposed that we can look at the strength of the social tie that device owners have amongst them and use that to deduce trustworthiness between the IoT devices. So it's like saying, I have an IoT device and my friend has an IoT device. We are both friends, and therefore my friend can trust my IoT device to give him reliable service in terms of or trustworthy services. Now, at the face of it, this looks like a very good approach, very, very simplistic in that manner. I can take trustworthy information from one network, use it in another. But there are a lot of cons of this approach as well. For one, you're basically saying that you're treating IoT devices as dumb devices. So there's really no point in saying that it's a social IoT network because you're not saying that IoT devices are free to make their own social ties. You're basically saying, let the device owners make those social ties and we'll just use them to make ties between the IoT devices, right? So it's a little contrary to what we've been saying so far, that IoT devices should themselves be able to make these social connections. On the other hand, it's also kind of regressive in some sense because, yeah, I mean, on one side, there's also Yeah, it's regressive because there's a lot of data that proves that trustworthy information that can be derived from one form of a network may not always correlate with the trustworthiness in another network. So all I'm saying is that the two may not be directly correlated together. So getting information from one network, using it in another may not be a very good model in all circumstances, in all cases. Uh, in fact, some of the initial proponents of the social IoT model also proposed a relationship-based model coming from how humans trust each other. So, do I trust my brother more than my friend, or do I trust my parents more than my teacher? So, they're all relations, right? And based on relationships, there is a level of trust that comes with the relation. So somebody even, in fact, the early proponents of social IoT even published a paper which said, why can't we use relationships between objects to be able to predict trustworthiness between the devices? And they came up with ideas like two devices can have a parental object relationship if they were built in the same production batch. They were built in the same factory, same time as part of the same batch. And we're saying they have a parental object relationship because they have the same characteristics, they have the same features, they have the same vulnerabilities, if at all. So they basically are siblings of each other. So they have the they're siblings, and therefore they have parental object relationship. They could have ownership object relationship, which means if there are three devices that I own, I'm the common owner. All these three devices have an ownership object relationship. Right? And they went ahead and said, okay, every relationship has an associated trust factor, and I can use that to build a mathematical model based on these relationship weights and thereby be able to compute relationship. Again, it's a nice way of looking at how humans operate, but there are always intricacies involved in these kind of models because I mean, I could very well say that I have a better trustworthy relationship with a friend than even my brother, let's say, or my sibling. I think that's always possible. So all these kind of models do exist. I'm not saying which is good or which is bad. It's just an introduction talk. So I'm just putting in front of you all the different kind of models that do exist today. Now, another important thing that needs to be assessed is uh, how strong are these trust models in the face of attacks that can happen. Right? So on one side, we are saying trustworthiness or trustworthiness management or trust models, they are falling under the broad topic of IoT security. Okay? Because they can be malicious IoT devices. How do I determine them? How do I know whether I can trust them or not? So basically a trust model is helping me build a more secure IoT network, a more trustworthy IoT network. On the other hand, the trust model itself may be vulnerable. Itself may be vulnerable to a variety of attacks. Okay? Let me give you an example of that. Have you ever come across situations where a seller sends you a product? Let's say you bought it on Amazon or you bought it on Flipkart. The seller sends you a product and he sends along a small chit saying, if you give me 5-star rating on Amazon platform or Flipkart platform, and then you send me a snapshot of that, I'll transfer 50 rupees into your Paytm account. What is he doing? He's buying your vote. Right? So that's a kind of an attack. And is the model resilient to that kind of an attack? If your entire assessment of trustworthiness is based on ratings, and if a particular service provider can manipulate that system to garner artificial votes or higher ratings, then he's basically attacking your model and your model is going to fail. So similarly, the challenges exist with all of these trust models. There are attacks like slandering attack or bad mouthing attack. Right? As a competitor, I may be selling the same products as some other service provider and I want to destroy that service provider by lowering his rating. What can I do? I'll start slandering him. I'll start giving him 1-star ratings, right? Bad mouthing him so that his overall opinion or rating goes down. I can also do a ballot stuffing attack, which is the reverse of a bad mouthing attack. I can collude with a group of people and say a particular service provider is really good, 5-star, 5-star, 5-star. The kind of example I just took, where I said, okay, I'll give you 50 rupees if you give me 5-star rating. It's kind of a ballot stuffing attack. Right? There can be on-off attacks, which means opportunistically a service provider may transfer or change its behavior between trustworthy to untrustworthy. Can your trust model detect that? So normally what a malicious user would normally do is he will initially behave very, very trustworthy. He will get very, very good ratings. He'll get a very, he'll behave as if he's very trustworthy. He'll garner a lot of votes. And when everybody has started to trust him and he has a lot of financial gain in that one time demonstrating untrustworthy behavior, he'll do that. So that's what we are calling as an opportunistic behavior. At that one time, he had a lot of financial gain to make by behaving in a untrustworthy manner, and he does that. That's what we call as an on-off attack. He may not always be trustworthy, may not always be untrustworthy, but keeps on oscillating between the two. Can the model handle that? Lastly, all of these attacks, they can really be accentuated by clubbing them with what we call as a Sybil attack. So what is a Sybil attack? A single node makes multiple identities of itself to make the attack more meaningful. So let's say I want to do slandering attack, or I want to do ballot stuffing attack. As a single individual, there's only as much as what I can do. But if I create 10 identities on Amazon using 10 different mobile phone numbers or 10 different email IDs, and then I execute the bad mouthing attack or the ballot stuffing attack. So it's 10 times more meaningful. So a Sybil attack is where a single node can make multiple identities of itself and make any of the other attacks more meaningful. Right? Is your trust model able to detect that and handle against that? So those are some of the attack scenarios that must be checked for every kind of trust model. So as I said, one, of course, is those four factors where we talked about how much storage is required, how much volume of information exchange is needed, what is the amount of information needed for one run of the trust measurement, how frequently do I have to do trust measurement. Those are all factors using which I can assess the suitability of trust models for social IoT networks. At the same time, I also need to look at these factors. How resilient are my trust models against these kind of attack scenarios? So if the trust model itself is not resilient, then I cannot end up making a secure or a trustworthy IoT network. Right? So in summary, as I said, it was more of an introductory talk, but in summary, let me just end by saying that trust models for social IoT, the topic resonates a lot with what is being done in online social networks and what is being done in online service platforms, marketplaces, and all. Yet the trust models may differ significantly. Online social networks follow more of an interaction kind of a model. Service networks follow more of a ratings kind of a model. Whereas with social IoT, neither of them may work very well because of the resource constrained nature of IoT devices. So you may want to go with something which is more hybrid, something which is more graph based, something which doesn't require a lot of data to be processed by your IoT devices, but it can augment or it can improve the accuracy of your graph-based models by using some of the other data that is available from the network, right? So more like a hybrid kind of a model is something that a social IoT network may benefit from. So it's an area of active research. People who are looking for a good topic in the space, trust models for social IoT is an area of active research. Um, we basically are there's a lot of work which focuses on trying to build models which can fit across heterogeneous devices. As I said, that's the importance. They can be models which can work on devices which have a lot of computational power, but models which can work across heterogeneous devices are the good models, right? And models which can work in multi-service networks, which means there can be different kind of services being offered, right? Irrespective of the topic, or can I, or let me say it differently. Can I build a trust model which can be topic specific? As we said, trust has that property that it is always topic dependent. So when I say multi-service network, the model should be extensible to handle all the different kind of topics that exist. Right? Finally, as I said, trust models can themselves be vulnerable and they can themselves come under a variety of attacks from malicious nodes in the network. So those issues also need to be addressed when building a good trust model for social IoT network. So with that kind of an introduction, I'll just close my talk and open up the house for any questions that you may have on this topic.
Thank you, sir. I am sure this insightful session has enlightened the participants about the real scenario. There are some questions by the participants I'd like to now take up with your permission.
Sure, please, Dr. Ritika.
Uh, First question we have, which standards are followed by social IoT networks and how strong is their actual implementation?
Okay, I think that's a kind of a problem that has been percolating for quite a lot of time now. IoT networks themselves are not driven by any fixed set of standards, right? When you look at IoT devices, there are, as I said, heterogeneous kind of devices that exist. When you look at the networks that they use to communicate, um, you could connect IoT devices over Bluetooth networks, over Wi-Fi networks, over long range LoRa kind of low power wide area networks. So the networking standards themselves are distributed. The devices themselves are distributed, heterogeneous. The networks are distributed. There is no single security standard that drives IoT networks. So social IoT, which happens to be a relatively newer concept in this entire area of IoT networks, it doesn't have as such any specific standard. A lot of research is happening in that area, and there are a lot of research papers that get published every day. But to call out any specific standard that might exist, that does not exist.
Okay, thank you, sir. So the next question we have, can the graph-based model and opinion-based model together be better for trustworthy IoTs or they have to work separately?
Yeah. So as I said, hybrid models are probably what needs to be looked at when in the context of social IoT, because as we said, neither a pure graph-based model can work very well because of its lower accuracy, nor can we use a completely dynamic interaction-based model because of the humongous amount of data that's involved. And therefore, a more hybrid kind of a model is required. Now, can that hybrid model be a combination of a graph-based model and an opinion-based model? Because, of course, as you rightly understood, an opinion-based model doesn't have the same volume of data exchange as a ratings-based model. So, in that sense, it can be a good approach. But will it work across all kinds of IoT networks? Will it be able to handle the attack scenarios that we just discussed? That needs to be looked into more detail. So I can just say that it's a good thought, but how much successful that kind of a model can be needs to be assessed based by looking at all the different attack scenarios and how it can handle those.
Absolutely. So next question we have, any real life SIoT devices which can be used in homes and offices or they are actually being implemented?
Yeah. So as once again, a relatively newer concept that social IoT is, it will evolve over, I think, a period of time. I would say the closest example could be the case or the first scenario for social IoT might be manifested with autonomous driving cars. So we're seeing a lot of focus towards self-driving autonomous cars, and V2V is an architecture that exists today. V2V is more like an M2M architecture in that sense, a vehicle-to-vehicle network where automotives talk directly to each other in a more kind of a mesh kind of a topology. And because vehicles are not so much resource constrained in that sense, I mean, if I'm buying a 15 lakh worth of a car or a 20 lakh worth of car, I won't be very put off if the cost of the car is increased by 10K in order to put in a good onboard computer system on the car, right? On the contrary, if I have a very small 500 rupees IoT device, a 10,000 rupees compute onboard computer cannot be put on it. So all I'm saying is a vehicle is one of those platforms where the resource constraint may not exist to that level. And therefore, a, V2V network could be one of the first scenarios where people can see cars talking to each other, more like a social network, and thereby making some intelligent decisions like exchanging amongst themselves the best route to a destination or exchanging congestion information on the road. All those kind of use cases can first be seen in a self-driving car kind of a car or a scenario. So that's what I feel about it.
Absolutely, sir. Very rightly said. So, with this, we come to an end to this wonderful session today. I would now request Professor M.N. Huda sir to kindly present a certificate to Dr. Nishant Narang sir.
So thank you so much, Dr. Nishit, for a very thought-provoking, though a very foundational talk on this trust management for the purpose of social IoT network. I think in coming days, we need to have much more sessions like this. This certificate is not for the purpose of certification, rather for the purpose of remembrance that you have been part of this webinar session, which in under WebEx as well as YouTube was attended by close to 300 people. So thank you so much. We'll meet again for another session in the same sequence.